Hello everyone, welcome to my next video lecture on machine learning. So today I'm going to discuss about the question most people ask when they first heard about the machine learning. Why do we need the machine learning in the first place? So nowadays machine learning is used in the most every field, such as it is used in the speech recognition, image recognition, and the detection of credit card fraudulence and many more. But the question still remains the same. Why machine learning? Okay, stick with me to the end of this video. You will know why we use the machine learning and why we need the machine learning in the first place. So guys, meet my students. So this one is Helsinki and Nairobi and Tokyo. Okay, let's get started. So why do we need machine learning? Some of you might say we want to automate certain processes using computer, but we have automated processes using computers for the last 50 years. So what's the difference? Why is the classical way of programming a computer not sufficient? I'm sorry, but let me ask you one simple question. What is an algorithm? You might say, in mathematics and computer science, an algorithm is an unambiguous specification of how to solve a class of problems. Okay, that's right, Helsinki. But have you noticed one thing? This definition is not bound to a code or say any programming language. An essential feature of algorithm is that it can be written down in plain text. For example, a cooking recipe can be considered as an algorithm as long as it doesn't contain an instruction like the salt to a taste, which require a personal judgment. But it is a sequence of steps following a certain defined rules. So I hope you got the basic intuition about the algorithm. Okay, yeah, I know you might be thinking why I'm going off topic. Actually, I'm not. I'm actually approaching towards a point where I can find answer of why we need ML in the first time. So guys, stick with me in this journey. You will know very soon why I'm talking about the algorithm and all. So now let's talk a little bit about the classical way of programming, shall we? The classical way of programming a computer relies on this general understanding of the algorithm. It applies to the apps, games, accounting, software, or an online shop, just to name a few. So in the classical way of programming, a developer or a product manager analyzes the problem, figure out the rules. In the development terms, in the development teams, these rules are written down in the different kind of human readable documents like specification, backlog, etc. And the coder code using that particular rule. Okay, so first they find the problem and they figure out the rules and the code. So this is the basic intuition of classical way of programming. Okay, for even better understanding, example of such rules are, for instance, if you sell a product, you have to add X percentage of VAT, or say store the number of product in the stock in the database table XYZ. The developer then translates these rules into the programming code that can be run on a computer. Now you might ask where the classical approach fails then. If you have that question in your head right now, that's actually a good sign that you are paying attention. I really appreciate that. If not, don't worry, I'm going to answer anyway. So before I answer your question, Nairobi, can anyone give me one example where ML is used? You might say image recognition. Okay, then let's consider image recognition. Okay, let's say if I give you an image of an walking elephant, can you write a code and print out as a walking elephant? You might say yes. Why not? I know some of you still quite not following me, but don't worry, you will get my point. Stick with me. Okay, now consider this Helsinki. What if I give you an image of sleeping elephant? Can you previously code predict this image as the sleeping elephant? Now I think most of you got the idea what I am trying to say. If you consider the rules Helsinki made so that he can solve the question I gave him in the first place, that is prediction of walking elephant. Now that same rule cannot predict the image of sleeping elephant. So when it comes to the problems like image, speech recognition, language translation, sales, forecasting, we cannot solve these kind of problems by the same approach used in the classical programming. Some of you might say, how could ML predict the images then? If you have this question in your head right now, that's actually very impressive. I like that. So in the machine learning, what we do is fed lot of data in the different position like sleeping, walking, and many more. Using this data, we train our machine. So we humans are able to identify objects with our eyes, talk to each other, talk to other people, or understand a written text, but we are not able to write down how our brain does it, what rules it follows to do the trick. Even though we know some of the rules in the meantime, it seems we are facing a fundamental limitation here. Nature is too complex, bears too many variations, subtleties, to cover it by the finite set of rules. You can easily figure it out yourself. Try to define the concept of an elephant that could cover all the different images in this picture. Picture was shown over here. They all come with different shapes, colors, and sizes, environments, or the materials. Some are real, some are statue, and others are painting. Still, we can identify them, can't we? Even there is just an elephant's eye, you can see. So this is why we need the different approach in this case. We are not able to write down the rules and the concept explicitly. You might now ask me, what is machine learning then? Sure, you want to know what machine learning is. So machine learning is basically a mathematical approach where the system analyzes the data, that is images, sound files, text, etc. for a certain patterns. And the trick is that the system figures out on its own which patterns to look for, usually by analyzing the thousands of examples. The system implicitly learns the rule. Example for identifying the elephant, which we are struggling to write down explicitly. I hope now you can decide whether a classical or a machine learning approach is required for your problem. If you are able to identify and write down the rules of your task, you're better off with the classical approach. There are exceptions in the science where we know the rules, but the classical approach is too computationally expensive. The use of machine learning is typically limited to a very specific set of the tasks where the classical approach fails, and these tasks are usually embedded in a lot of classical coded state. If somebody wants to sell you a system with a level AI, make them explain to you where machine learning is used specifically, and also why a lot of classical software is just rebranded as AI. So I hope all of you now understood why we need machine learning in the first place. So Stanford computer scientists have developed an artificial intelligence system that enables a robotic helicopter to teach themselves to fly difficult stunts by watching other helicopters perform the same maneuvers. The technique is known as apprenticeship learning. So you want to know what machine learning is? Okay, so machine learning is basically a mathematical approach where the system analyzes the data, that is image, sound files, text, etc. for certain patterns. The trick is that the system figures out on its own which patterns to look for, usually by analyzing the thousands of examples. The system implicitly learns the rules, example for identifying the elephant, which we are struggling to write down explicitly. I hope now you can decide whether a classical or a machine learning approach is required for your problem. If you are able to identify and write down the rules of your task, you're better off with the classical approach. Okay. The use of machine learning is typically limited to a very specific set of tasks where the classical approach fails, and these tasks are usually embedded in a lot of classically coded steps. I hope all of you now understood why we really need machine learning. So Stanford computer scientists have developed an artificial intelligence system that enables the robotic helicopter to teach themselves to fly difficult stunts by watching other helicopters perform the same maneuver. The technique is known as apprehensive learning. The result is an autonomous helicopter that can fly a dazzling stunts on its own. So watch this video.
This program is brought to you by Stanford University. Please visit us at stanford.edu.
So what you're seeing today is by far the most difficult aerobatic maneuvers flown by any computer-controlled helicopter.
The goal is always for us to take really hard problems that humans are very good at solving. For instance, Garrett can pick up any helicopter, even ones he's never seen, and go fly amazing aerobatics. So the question for us is always, why can't computers do things like this? So our goal is to build software that can learn to go fly a helicopter the way that a human being can, and that way we don't need so much engineering effort to build control systems like this.
So the basic technology used to develop the helicopter controller was a type of AI algorithm, type of artificial intelligence algorithm called apprenticeship learning. What the helicopter does is it watches a human pilot fly the helicopter around for a while, and by watching a human pilot learn to fly, it then learns to fly by itself. And so what it does is it watches the person fly, and then it will try to fly the same stunt maneuvers by itself, and maybe try a few times until it sort of nails the maneuver. And what you're seeing is the end result of this machine learning process called apprenticeship learning.
So basically what the software does is it acquires all of the measurements off of the instruments, and then it puts them into something called a Kalman filter that figures out where the helicopter is, which way it's facing, what its velocity is, and so on. And then that information is fed into a control system that decides based on where the helicopter is and where we want the helicopter to go. The controller actually computes new controls to send out to the helicopter every 20th of a second.
What we do is we collect several demonstrations from our expert pilot, and then our algorithms process these demonstrations to figure out what would be the ideal version of, let's say, a flip or a roll or a loop, etc. And then we use that as a specification for our control problem. And this allows us to find trajectories that are better trajectories than the pilot can demonstrate.
The helicopter does.
So guys, I hope you enjoyed my video. In the next video, I'll talk about the supervised learning algorithm. We'll see the math behind the supervised learning algorithm. If you liked my video, give it a thumbs up and subscribe my channel towards AI. Okay guys, have a nice day.